Hello, this is hi everyone. I think it is very happy to share our company and product to you today. Um, so let's start. I think this is today's agenda. The first part, I would like to give a short introduction about our company and then the products. Secondly, I would like to share our understanding and the solutions about the electrification. The third part, considering for the previous 2 years, we continuously sharing our sensor technology. And also yesterday we shared a deep dive about our isolation technologies. Therefore, for today, I will only focus on the power gate drivers and the power device part. The last part is a summary. So firstly, I think NOVOSENSE is a new face in globally, and we are analog and mixed signal IC company, and we established at 2030, and we issued our IPO at 2022. Especially, I would like to highlight is that we have more than 1,100 employees. More than half of them are R&D guys. And also for last year, what we achieved is 273 million US revenue, and which is showing 50% year-to-year growth, and then roughly 28% is invested for R&D as well, which means that we are targeted for the technology innovation and the leadership, and we also commit to do that. To better support the customer around the world, we also set up our sales network globally, including China, Japan, South Korea, US, and also Germany as well. So welcome to our Munich office to come by and discuss more about the solutions. So you can, at the very beginning, we are start from the consumer markets, and start from 2015, our company decided to enter industrial and automotive market strategically. And from then, in the past 10 years, we released the automotive sensors, current sensors, press sensors, and also the isolators, gate drivers, motor drivers, power management ICs, and also in the past 2 years, we also released our specific SoC and also power device for the automotive related applications. I think we are targeted to expanding and also enriching our products in the automotive applications, and especially I think to guide our product expanding, that is mainly guided by our application understandings and also application innovations. Therefore, you can see that for the past years, we have our products are gradually widely used by industrial and automotive customers. And especially for automotive part, for the related applications, our revenue occupied roughly, automotive is roughly occupied roughly 36% of our revenue, which will be much higher in this year. I believe may touch about 40%, something like that. And as we all know that electrification and intelligence is a major trends, technical trends of the whole automotive industry. Therefore, we on the electrification and also on the intelligence, you can see that we invest a lot. We have a comprehensive and also full category products for the automotive related applications. To give an example is that for automotive chip shipment, till now, we have more than 600 million ICs shipped globally, and also especially on the e-powertrain and the inverters, OBCs, and the compressors, our focus applications, you can see we supported more than 400 tier ones globally. This is pretty much about what is NOVOSENSE. And then I will share our understandings about electrification, especially the technical trends of China market. As we all know that right now, the NEV is quite a hot topic. Right now, the market is there. And at the very beginning, we all know that the market is triggered by the policy and the subsidy. And especially in China market, I think the NEV development plan, the policy is set as the basis of the growth of the NEV market. And then I think to guide the whole market healthily growth, then the technical roadmap 2.0, especially on the technical specs, is launched and to explain more about the technical trends. Therefore, you can see that the whole system level biology, whole system level efficiency and the power density, and also the motor efficiency is the key focus in previous technical roadmaps. But as for now, I think it's already 5 years past. So the new 3.0 roadmap is the draft from 2 years ago and the target to launch at this year. Therefore, I think per our understandings, not only focus on system, but also from system to component level, and also from the new updates is from system to component level, and also they will focus not only on performance, but also on the reliability and quality as well. Therefore, based on the discussion with customers and our understandings, we summarized the technical trends of the powertrain system. I think the purple one is what we updated per the 3.0. And you will see that besides the voltage, the efficiency and density and the cost, that is the key factors. Besides that, the safety and the reliability is discussed and talked more and more in the no matter policy side, but also the customer side. Therefore, for the system level designs, what is the key focus accordingly is that how to reduce your losses, how to withstand high voltages, and how to have your ICs with more CMTI features. And then for density part, I think the in system integration and also how to integration more features for the whole system level, that will be very important. And especially on the safety and the reliability side, for function safety, lifetime reliability is more and more serious consideration for the system level designs. Cost always will be the key. And according to the system understanding and the system focus, I think that will give a lot of challenges and a lot of requirement to our IC companies, how to you design your driver IC. And especially, I think the key component, the power device, that is, do you have the new technologies, how to use that, and how to do the integration, and how to do the optimization. I think we listed here is that, like for the high voltage, especially for gate driver, we know that for high voltage, silicon carbon is there. For the gate driver, how to select the suitable driver for silicon carbon device, like CMTI, and for the high DVDT, and for the density part, can you integrate the output current within the IC together, and also could you provide the low probe delay to mitigate to better drive the ICs? And also, can you have the smaller package to have higher capacity? That will be also considering for the IC part and also for the power device part. And especially for the safety and the reliability, I think the function safety and whether you really do a lot of fully test to make sure your device is stable, is reliable, that is also considering, and the lifetimes, PPM is talked a lot more and more. Therefore, I think we can summarize us here is that right now for the high voltage, I think from the silicon device to silicon carbon based and also gain natural is much more, focused by OBC and inverter applications. And also for the density part, can you do the integrations no matter the gate driver or power device? And also for the safety reliabilities, I think function and automotive qualification and quality is a key. And especially for cost side, I think not only you should lower your price, but also you should do some system level innovation, chip level innovations. This is the major, we see that the technical trend for all this from the system to the chip levels. And let's take the inverter system as an example. We all know that considering different applications, you have different requirements. Therefore, there are different selections for the power device and also for the ICs. For inverter, we all know that the power is extremely high, like reach the 300 kilowatts above, but the switching frequency is not so high. And for the high voltage, I think it's a major trend, and that it will make silicon carbon device penetration rate increase. And high power density, we see the event in the past 3 years. We see a lot of innovations in the package level, especially on the power device, to have a very high power density. And for this application, I think function safety and reliability will be the key. Therefore, for the gate driver side, you will see that we, according to the technical trends, we also selected and upgrade our gate driver accordingly. Like previous, our 660 is automotive version, and it's only with the DSAT protection and ASC protections, but we upgrade to the 67 series with more sensing inside, which match to the high integration, more functions, and more protection features to make customers' system more compact. And also, we mentioned that safety will be the key focus from customer side. Therefore, we have the function safety SLD gate driver. Also, with to considering the silicon carbon modules, we also improved our output current and integrated with a 12-bit ADC inside, which you can use for the temperature sensor and also for the voltage sensors. Then with the high integration concept for the driver ICs, you can simplify your designs. Therefore, for the OBC DC-DC applications, I think it's quite a different versus inverter, no matter the power, but also the frequency part side. We know that the OBC DC-DC, even the high power is increased from 3.3 to maybe 22, but still to 6.6 and 11 kilowatts is still the mainstream. It's much lower than inverter, but the switching frequency is much higher. From inverters 10 kilohertz rise more than 100 or 200 kilohertz, which means I think that is quite different systems. And you will see that for the high voltage in this application, silicon carbon is much more has much more penetration rate in this application. And also considering the very high switching frequency, you will see that the GaN device is focused by this application more and more. And for the high power density part, I think package innovation. At the very beginning, we see a lot of OBC, DC-DC tier ones, they are supporting their system with a bigger one. But right now, the power density is much higher, and then they will change the package for the power devices and also require more and more compact and simplified design for that. Reliability part, I think the function safety not so high as inverter, but the function safety concept is raised B plus as well. And quality, of course, that will be the key. And especially for this application, you will see that considering the switching frequency is much higher, therefore silicon carbon penetration rate is much higher. And for gate driver part, I think the Miller clamping series is a must-have function to do that. And then for the power device part, as we mentioned, that silicon carbon is more and more adapted, and especially on the top side cooling and the other double side cooling package is will be the future trend for these types. Different with inverter and OBC, DC-DC applications, like the e-compressor and the PDC, I think is kind of similar. The power is not so high, and the switching frequency is also not so high. Like the PDC is 700 hertz. I think it's quite different applications. For this application, I think a gate driver, not only the previous we mentioned the function safety is not needed, but automotive grids will be needed. And also we have non-isolated gate driver used in these applications. Considering the power rating and also the switching frequency, silicon carbon is only used for high voltage systems, and still the IGBT version is a major or the mainstream. And even with the IGBT, I think previous customer with the THD package right now, customer are considering the new SMD package as well. I think for this area, not only silicon carbon, but also IGBT for the new fancy package will be also the key interest for these applications. For that, I think we shared our understandings on the application levels, and then we will focus more on the gate driver and the power device part. So I think per these 3 days event, we see a lot of silicon carbon modules, gate neutral devices as the best friends come hand in hand. Gate driver, I think I would like to update this part. For the silicon carbon device, we know that they have very high DIDT, DVDT features, and which means how to select your suitable gate driver will be much more important. So we summarized our understandings per the customer request on this part and discussed with customer, and per their requirements, we listed the key features and criteria how to select a good gate driver here. I think considering the higher DIDT and the DVDT, higher CMTI performance will be definitely the key, and also withstand high voltage for the 800 watts system is also important, especially like the silicon carbon. I think the considering all the threshold for the gate is not so high, then how to mitigate the misleading turn on will be important. Then the Miller camping will be the key to select the gate drivers. Therefore, as we mentioned, different application requires different gate drivers. This gate driver integrated, this gate driver is targeted for the main inverter application. According to this application's features, I think you can see that considering the high power modules, the output current is improved, and also the high voltage system isolation will be the key, considering the high integration requirements. I think the 12 bits ADC sensing and more, considering the powertrain is the key component in the whole e-mobility, and how to safe and stable turn off, especially on the extreme event, will be the key. More and more protection functions are needed. So we have all these functions in one, which is a function safety SLD gate driver for this market. And if you do not need so much, higher function safety concept or always other concept, you can do your own function safety approach. Then this is an automotive grade gate driver. It's kind of cost performance version. Then also you can with the integrated higher output current and also the sensors together. We also have this cost performance version for inverter, that is. And for this page, I think as we mentioned, this is suitable for OBC, and also you can use it for the e-compressor. That is with the Miller camping gate driver. Also we upgraded for the high voltage, and also with higher output current version. This is pretty much our understanding silicon carbon driver for the e-mobility powertrain systems. But as we all know that considering the very high switching frequency, GaN is adopted more and more, and especially on OBC applications. So we would like to share our understanding to how to select a GaN driver IC for you. And as we all know that the GaN gate driver GaN device is quite different versus silicon carbon. Not so higher voltage gate voltage range is limited, and they also need the stable power supply for that, which means you should have an out-stage LDO to make your voltage very stable. Otherwise, it's not so stable. And especially on the GaN device, I think the IDT, DVDT is even much higher than the silicon carbon device. And the separate output pins is also too important, considering the diode may give a threshold, because the GaN device threshold is much lower, roughly 1 to 2 watts. Then the design circuit, the diodes forward voltage is also important for that. So we need to separate the output pins to better drive the GaN device. And then for some high voltage and high power applications, especially hard switch parts, the negative bias is the key to have your device, especially on E-mode device, to help your device safely turn down. This is the key I would like to highlight about the GaN driver ICs. Therefore, for the OBC DC applications, we launched the automotive low-side GaN drivers. And also, we have the 700 half-bridge gate driver integrated, what we mentioned, LDO to make a stable driver range. So for the high voltage and hard switch applications, we also have the negative output bias integrated with gate driver together. Besides that, to better understanding how to fit the gate driver technologies, and we also have the power device. And for the silicon carbon device, I think the major features is that we can compatible with the 50 and 80 watts mode, and 20. And if you can drive with higher voltage, then I think you can get 20% lower RDS(on) and higher BVs. Especially we optimized the diode voltage to have better efficiency. I think package right now we are focused on the discrete solutions, especially for OBC compressor applications, and also we are doing the new package for the future. Considering the e-compressor and the PDC applications, as we mentioned, the cost performance will be the key. Therefore, we also have the IGBT technology launched, which optimized the conduction performance, and especially we optimize the short circuit performance as well. Sorry, I will do it quick. And I think as we mentioned, safety and quality will be the key in automotive area. Therefore, I think we also have very serious quality process and the system to do that. We start from the customer requirements and end with the customer certifications. That is go through the whole design and the manufacturing process. To take our key gate driver as an example, I think not only we do the normal CP or FD test, but also we do a lot of extreme event tests to make sure our gate driver is robust for this area. So not limited to the CMTI passed every gate driver, we have the data sheet 150 kilowatts per nanoseconds. In fact, we will test more than that to give much more room for customer side. And besides that, like the DPI injection test, like the narrow pulse withstand voltage test, and also the cosmic ray test, we will do the extreme test to make sure our gate driver is robust enough. And besides the chip level test, I think considering we also invest on a lot of system ICs. We also do the double pulse and even the prototype, system level test to verify that. If you can come to our booth, you will see that we have a lot of system level demos to show to customer to better support and better verify our products. And this is on the product level, and especially when you have your product production, how do you make sure your product is continuous, reliable? I think a qualification plan is one part. And another part I would like to highlight is that, especially on silicon carbide device, everyone has said your process is not so mature, maybe not so stable when you do the long-term production. I think for NOVOSENSE, we have our continuous OKR and DPL approach. Every bunch we shipped, we will do the OQC monitor to make sure this bunch is reliable, to make sure our device is reliable. I think that is what we thought, how to keep your products continuously have a good quality. This is pretty much about my part. At the last, I would like to highlight is that not only gate driver and the power device, we target to provide the one-stop solution to your guys. Sorry. Thank you. Thank you for your time.